Hello class. This is PBasic Command 7 video. In this video I will concentrate on the RC time command, the if then command as before, and also the do loop command. Going back to our microcontroller, I'm basically running the same process or the same process control loop that I did in the past. This time I will be reading information from a single port, so it may look like I'm reading in serial information, but actually I'm reading in a digital information, but I'm using the microcontroller to measure the time it takes for the value to change from one state to another state. We know that 1.4 volts is the voltage threshold for this microcontroller. So we're going to initialize the circuit at 0 volts, and then the microcontroller is going to determine how long it takes for that voltage to reach 1.4 volts. That time will then be saved into the microcontroller as a variable that represents the, the time for the different resistance that's connected to the capacitor. So if you have any device that changes its resistance with a physical dimension such as light or weight or pressure, if you have a variable resistance sensor, then you can use this as an analog input. Or if you have a component like a humidity sensor which changes capacitance value based on the humidity, you can also use that as a sensor directly into the microcontroller without using the analog to digital converter. This time then becomes your analog variable within your program that you can check to see if it meets one of your conditions. Let's look at our program number 7. Again, I've set my directions. I've defined a variable that I'm going to use to save the information. Now I'm going to change this because actually the command that I'm using uses 16 bits to save the information. It's called the RC time command, and this variable in this third position is a 16-bit word. So I need to save a space for that word. I'm going to use pin 15 to turn my LED on and off, and I'm going to use pin 2 to measure the variable time. I initialize my variable to X, and this is a 3-step process. First, I'm going to turn off the input circuit by making it 0, which basically means I am discharging the capacitor. Let me try to explain to you the principle quickly. We have a capacitor and we have a variable resistor. Now, if I put 0 volts here, then what's going to happen is that this capacitor is going to discharge to 0 volts. Now, if I take that same circuit and I quickly change this to 5 volts, I quickly change that to 5 volts. This capacitor is not going to go to 5 volts immediately. It's going to take time to charge up. I'm sorry, I made a mistake. principle is this. If I make this up here 0 volts, then of course the capacitor will go to 0 volts because all the electrons will discharge through the other 0 volts. But if I quickly change this to 5 volts, then current will go through the resistor and charge will go into the capacitor, and the voltage at this point will begin to rise. And we know from our DC circuits class that it will rise up at a certain time. Eventually that voltage will get to 1.4 volts, and the mic controller measures how much time it takes to reach the 1.5 volts before stopping measuring. And that number depends upon the value of the resistor or the value of that capacitor while it's charging. So that time will be saved in X. And then, of course, the same thing as in the other program. It will display that value. Then I will use the process to determine whether I want to turn the LED off or on, depending on whether the value is less than or greater than. Now for the demonstration. You can see that the LED is in the off position. Why is this? This is because in the beginning, the time here is 34. And in our program, if it's less than 75, it will turn off the LED. Now I'm going to change the value to a higher number. And you will see that the LED has come on. Wrong video. This is the video. The LED has come on. Let me see if I can show you both screens at the same time. Here's this screen. Here's that screen. I'll try to turn on this screen. There. This is what I want you to see. You can see the LED is on. Why? Because the input, I'll get it straight soon. There. Because the input is at 99. And now I will change it to a number less than 99, less than 75, and the LED goes off. Once again, above 75, LED on. Below 75, LED off. So that demonstrates the operation of the RC time command, which can be used as an analog variable in your program directly without using the analog to digital converter. However, remember, you must have either a variable resistor or a variable capacitor in order to use this function. If your sensor is not a variable resistor or a variable capacitor, then you must use the analog to digital converter to change your analog voltage into a digital binary number. Thank you.